last section we're going to take a look at is 4.3, and this is on the law of cosines. So let's just summarize. What were the three types of problems that we could do with the law of sines? Yep. Angle, angle, side. Yep, that's one. Yep.
Angle side.
Angle, side, angle. That was the second one. And what was the third one? Yep.
Side, side.
Side, side, angle. Remember, the third one, that's the one where you have to check for the 0, 1, or 2 solutions. You do not have to do that with the first type or the second type. Okay, so that's law of sines. Well, there are two other types of triangles that are solvable that we have not talked about. Anyone have a guess just based on rearranging those letters? Yeah?
Side, side, side.
Side, side, side is one of them. And there's only one more. Yeah? No, that wouldn't be possible to solve. Because if I told you all the angles in a triangle, like if I said I'm thinking of a triangle where the angles are 60, 60, and 60, that's equilateral. But you have no way of knowing how big of an equilateral it is. Yeah?
Would be side angle side.
Side, angle, side. Yeah. So no matter which type you're solving, you always need to know at least one side. Otherwise, you don't have a reference on the sides. All right, so we're going to focus on the two that are on the right. And we're going to look at, well, why can't we just use law of sines? Why do we need a different formula? Let's look at this one. Okay, we are going to solve this one in a minute after I show you the law of cosines. But let's say we wanted to try to solve it with law of sines. Okay. To use law of sines, how many rows in that table do you need to use at a time? Two. You need to pick two. Right. Let's say we pick the top two and we try to set that up. You'd have sine of alpha over 2 equals sine of beta over 3. What's wrong with trying to solve that now?
There's two variables we don't know.
Right, there's two variables you don't know. We're not going to be able to solve it if there are two variables. We only can have one. So instead of picking the top 2 rows, then let's pick the bottom 2 rows and try that. If you pick the bottom 2, how many variables are there that you don't know? It's 2 again. So the only other combination we could try is the first and the third row. If you pick those 2, how many variables are there that you don't know? 2 again. So no matter which combination of rows you pick, you're always going to be missing 2 variables because you do not have a full row. That's a problem for the law of sines. It's not going to work. Right, so that's where the law of cosines comes in. And the law of cosines enables you to solve triangles like that. The one on the left is side, angle, side. Bless you. And the one on the right is side, side, side. Either one of those situations, you need the law of cosines. Now, the one on the left, that is always solvable, always. And it will always have one solution. The one on the right could either have no solution or one solution. It can never have 2. Okay, so that's the nice thing about law of cosines. You never have to worry about 2. That's impossible. But this still could have no solution. What did we say about, there's a rule with the sides in a triangle? Anybody remember what the rule is? Yeah?
The 2 shorter sides have to be more than the longest side.
Yeah, well, any 2 sides have to add up to be more than the longer side. Okay? So if I gave you sides of like 1, 1, and 300, you can't make a triangle with a 1, a 1, and a 300. They won't connect. So that would be impossible. But this is one that would work because 17 is bigger than 6, 16 is bigger than 7, and 7 plus 6 is 13, and that's bigger than 10. So that it is doable to make a triangle with those sides. So checking for no solution, that's very, very quick. All right, that's what I always do first on side, side, side. Side angle side, you don't need to check anything. You can just start the problem right away. All right, so law of cosines. It's going to use the same labels we've used before. A, B, and C will be the sides. Alpha, beta, and gamma will be the angles. And the law of cosines can be written in different ways, but that's how it starts out. Does that look like anything we've done before? Yep. Yeah, it looks kind of like Pythagorean theorem. But we know from using Pythagorean theorem, we can only use that on what kind of triangle? Yeah?
Right.
A right triangle. Right. So there's got to be something more. So it starts out like the Pythagorean theorem. One side squared equals the sum of the other two squared. But then we have to subtract something. And this subtraction is going to account for the fact that you don't have a 90-degree angle. So it's kind of like Pythagorean theorem with an adjustment. That's kind of like what it is. So the adjustment is 2 times the product of the two sides that you wrote down just before it, the A and the B, times the cosine of the angle across from the letter you started with. What angle is always across from C? Gamma. Okay, so that, make that a little better, is the law of cosines. What's important, though, is not the letters you're using, it's the pattern of the letters. Because you could write A, B, and C for the sides. You could use X, Y, and Z, P, Q, R. It doesn't matter what you use as labels, but it's the pattern of them. Right? So the general pattern is one side squared equals the sum of the other two minus twice the other two, cosine of the angle across from what you started with. So let's see if we can write it for B squared. What do you think would come next after the B squared?
A squared
Mm-hmm.
minus C squared. Or plus.
So A squared plus C squared. All right. Then what? Yeah.
Minus parentheses 2AC.
Minus 2AC. Yep. And the last part? Yeah.
Cosine beta.
Cosine beta. Yep. Okay, so that's not a different formula. It's the same formula. You're just representing the pieces of information different ways. Okay, but it always looks something like this. That's what the law of cosines looks like every single time. You just have to fill in all the boxes. Okay, so you have to know the pattern. All right, so let's look at it one more time. What if it started with A squared?
B squared plus C squared.
B squared plus C squared.
Minus 2BC
2BC
cosine alpha.
cosine alpha. Yep. And if I wanted to keep going, I could do x squared equals y squared plus z squared minus 2 times y times z. I could just keep writing the pattern as many ways as I want. Any question on that? That's pretty much it. That's the formula. So now we're going to plug in and we're going to solve. There are two different cases that happen with law of cosines. When you use law of cosines, if it's a side-side-side problem, you never need to solve for a side because you're given all the sides. You have to solve for an angle, and an angle. So you have to do the same thing 3 times. If you have side angle side, you're not doing the same thing 3 times. One time you need to solve for the side you're missing, then another time you need to solve for the angle you're missing. So the side angle side case covers more, right? There's more there's two things that can happen. Finding a side, finding an angle. Here, there's only one thing that happens. Finding an angle, finding an angle. It's the same thing twice. So we're going to start out with side, angle, side, because that covers everything. So that's the problem I had up at the beginning. Again. So we already went through why you can't use law of sines. You don't have a full row. So that means you need to use law of cosines. When you are solving a side angle side problem, which is, if you drew that, that's what this one is. Okay, if you put A here, alpha goes across from it. B, beta goes across from it. C, gamma goes across from it. Side, angle, side. Okay, so it's SAS. When you are solving SAS, you need to find the side you're missing first. You don't have any other options. You have to find the side you're missing first. The reason is because looking at the law of cosines, every version, no matter how you write it, has every side in it. The top one has A, B, and C. The second one has A, B, and C. And the third one has A, B, and C. We're already missing C. Okay? So that's something that we're missing no matter which version you want to use. We don't know C, we don't know C, we don't know C. We can't be missing anything else. So out of those three versions, which one would I have to plug into based on the fact I know A, I know B, and I know gamma? You've got to pick a version that has all three of those in it. If you don't, it's not going to work. A, B, and gamma. Yeah, it would be version 1. Okay? It's the version that has gamma. It's the only one with gamma. Okay? We know A, we know B, we know A, we know B, and we know gamma. We can fill in everything on the right side of the equal sign. So that's the one we're going to use. All right, let's fill it all in. So C squared. I won't do any of it out the first time, but after we go through the first one, I would probably just write 4. I wouldn't write 2 squared, right? Because now it's an extra step. I have to do that out after. Okay, so C squared, A squared, B squared, minus 2 times the product of the two sides I used right before it. 2 times 2 times 3. Times the cosine of the angle across from the letter I started with. I started with C, the angle across from C, gamma. When you're solving for the side is pretty much by itself the whole time. I mean, yeah, I got to take a square root when I'm done to get rid of that exponent of 2. But other than that, everything is on the right side. What's 2 squared? 4. And 3 squared? 9. So let's do all that together. 4 plus 9 gives me 13. What's 2 times 2 times 3? 12. Yep. So 12 cosine 60 degrees. I don't really need parentheses around the 60. It's just that's what the calculator is going to do. So I was trying to make it look like the calculator does. All right. Now let's. What we've done up to that point, we haven't rounded yet. Okay. Let's leave it and get C by itself, because anything else we do now, we've got to type in a trig function. All right. So the next step is 12 cosine 60, but I'm not going to do that out. How do I get C by itself here? Square root it. So that's what I'm going to type in on the calculator. And up to that step, everything is exact. I've done no rounding. Okay. Now I'm going to round. So it's the square root of 13 minus 12 cosine 60. Okay, that's simple enough. The calculator will do order of operations, no problem. It'll do 12 times cosine first, because multiplication comes first. And then it'll do 13 minus the multiplication. All right, so for side C, we get 2.646. And if you do it that way, there's no reason why everybody should not get 2.646. You shouldn't get 2.649, 2.642. It should be 2.646 because there was no rounding. Okay. If you have decimals and you round, like let's say you round every time you do a calculation, that is going to throw your answer way off. Okay, so we want to do as little rounding as we can. All right. So 2.646. All right, now we know that third side. This is the kind of triangle it was originally. Side angle side. What else is it now? It's also side, 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 because you know all three sides. Well, if you think of it as side, 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 you're still doing law of cosines again. It's also one other type. What other type?
Side.
It is. It's a side, and an angle not between them. Or you can think of it as a side, and an angle not between them. There's a couple ways to think of it. We could do it as side, side, angle. But if we think of this problem as side, side, angle, what's the issue with that? Yeah?
It's law of sines.
That's law of sines. And what specifically about side, side, angle? Yeah?
It could have multiple solutions.
Yeah, then we got to get into the one solution, two solution, no solution stuff, and I really don't want to do that. All right, so because we don't want to get into, we're worrying about the two solution, no solution, one solution, all that stuff, we're just going to finish this problem with law of cosines. So if you start with law of cosines, you want to finish with law of cosines. Okay. All right, since we know all three sides, you can find any angle you want. Okay? It doesn't matter if you do alpha or beta. Okay, so let's do alpha. Find alpha. Okay. If you want to find alpha, you have to use the law of cosines that has alpha. That's going to be the third one. That's going to start out with a squared. Since I know the pattern, all I have to do is figure out what letter to start with. And then for me, the rest of it just kind of falls into place. So if you're starting with a squared, it's going to be b squared, c squared, minus 2bc cosine alpha. Okay. And let's fill it in, and we'll do some of the things out as we go. Okay. Let's start with a squared. How much is that?
2.
4. And b squared. How much is that? 9. Now, for c squared, what I would do is type in that. That is as an exact answer as you're going to get for c squared. Right? So let's do 13 minus 12 cosine 60. 7. If I had taken what I had for c and squared it, 2.646, I would have gotten that. Are those the same thing? No. The reason the bottom one is like that is because we rounded. Right? If you go back to what you had at this step, there was no rounding. And it gives me a nicer number to work with. I don't have to work with a decimal. Okay. So c squared is 7, not 7.001. 7. Okay. Minus 2 times b times c. Okay. Well, what's 2 times b? 6. Now I do need to use this. Okay, so I am going to have to use 2.646. So 2 times b is 6. 6 times 2.646. That's 2 times b times c. It's 15,876. Okay. So now, what's different about finding an angle compared to finding a side? When you found a side, the side is pretty much by itself. When you find an angle, it's not. It's as not by itself as possible. Everything is over with the alpha. We need to move everything away from it. Okay. All right, so what could I do first on the right-hand side? This doesn't involve moving anything to the left yet. Yeah?
Come on, like that.
Yeah, I can combine like terms. What are my like terms I can combine?
4, 17, and then once you get that, you subtract 15.
Can you wait, say that again?
9 plus 7.
Okay, yep, and what's 9 plus 7?
16.
So that gives me 16 minus 15,876 cosine alpha. Okay, I can do that. What would I do next?
Can you just subtract
Subtract.
the 16 minus the 15.876?
Well, what if you had this? Could you do 16 minus 15 there?
No.
No, because the 15 is being multiplied by something that has a variable you don't know. While the 15 is being multiplied by a variable we don't know here too. So you can't do 16 minus 15 because these are not like terms. Whatever your next step would be in this equation, that's your next step in the one above it. Yeah?
Subtract 4 on both sides from 16.
Subtract what on both sides?
Or is it divide 4?
Well, we're trying to get x by itself. So we got to get rid of the 16 and the negative 15. So there's two operations we would have left. Yeah?
Subtract 16.
Subtract 16 from both sides. Yep. So that's going to give you negative 12. That's gone. Equals negative 15,876 cosine alpha. All right. Now what we have at this step is basically something like this. You have a number equals another number times a letter. What would be our next step now? Yep.
Divide
Yep. And what would you divide by?
15.876, negative 15.
Right. Negative 15,876. That's going to cancel the negative and the 15. Okay. And do it here as well. And when you divide that side, those negatives cancel. Okay. Now, don't do this out. If you do that out, that's just another rounding you're going to be doing. We've already done some rounding, so I want to avoid more. So leave it as 12 divided by 15,876. Okay, so now we've got that. And what would be my last step to get alpha by itself? Yeah.
The inverse of cosine.
Yep, I'm going to take the inverse cosine of what's on the left and what's on the right. Does anyone remember when we graph cosine, what was the highest that regular cosine ever goes? Goes up to what number on the y-axis? Goes up to 1. What that means is this number can never be bigger than 1. If you try to take the inverse cosine of a number bigger than 1, you're going to have a problem. Right? It's going to give you an error. What's the quick way that you can look at a fraction and tell if it's under 1? I mean, I don't know what this is exactly because that's pretty messy to do out, but I know it's less than 1. Yeah?
Denominator is larger than the numerator.
Yeah, the denominator is bigger. So if you ever get to this step and the numerator is bigger, just stop. Something's wrong. Okay? The denominator always has to be bigger. Or you're going to get an error when you type it in. All right, so inverse cosine of 12 divided by 15.876. So that gives me an angle of, well, we're going to round that to 40.900. So it rounds up that much. So 40.900 for the accuracy. Okay. So that's alpha. And now for beta, well, we know two of the angles. So what could we do to get the third one? Yep.
Add them both and subtract one.
Right. By doing that, you're relying on alpha. So if you got alpha wrong, well, then you're going to get beta wrong if you do it that way. But you already had to use, you're going to have to use something you calculated anyway. So if you got C wrong, then the rest of them are going to be wrong. There's no way around it. So we've already relied on C to figure out something, so we'll just add them up and subtract from 180. Or subtract them from 180 one at a time. 40.9 minus 60 gives me 79.100. Okay, now if you got an answer of like 79.102, I would give you credit for that. That's not that far off. But if you get an answer of like 79.5, that's too far off. Okay, if we're going to 3 decimal places, there's no way this one should be off by like 4 or 5 digits. Shouldn't be. All right. Okay, so any questions on that one? All right, so that's a side angle side, and that's the harder one, because you got to know how to do a side, and you have to know how to do an angle. Right. Let's look at this one. This is not side angle side. Don't even really need a diagram. Which type is this? Yeah,
Sorry.
it's side, side, side. Now, before we go any further, what should we check right away? It's going to take like 10 seconds, real quick.
See if there's
See if what?
see if there's a solution or not.
Okay, how do I do that? How do I see if it has a solution or not? Yeah?
Two sides added should be bigger than the third.
Right, just check that any 2 sides added together are bigger than the third. 4 plus 3 is 7, that's bigger than 6. 6 plus 3 is 9, that's bigger than 4. 4 plus 6 is 10, that's bigger than 3. So this is a solvable problem. If this last number was like 65, then no, that's impossible. Because 4 plus 3 is only 7, that's not bigger than 65. Okay. All right, when you know all 3 sides, you can find any angle you want first. Because, go back to your formula, you know A, you know B, and you know C. So you know all of those, all of those, all of those, all of those, all of those. The only things you don't know are what I just circled right at the end. You have everything else right up to that point. So it doesn't matter which one you use. We've already done it starting with A. And we did one starting with C. So let's try starting with B. Okay, so let's find beta first. Purely just to practice a different version of the formula. All right. What I like to do is write the formula down first. Then I don't have to try to think about what the formula is and plug in at the same time. Okay. To find beta, how does my law of cosines start out? Yep. Yep, b squared.
Equals A squared plus C squared minus 2AC cosine
Cosine beta. Now, we'll fill all that in. And as we go, we'll do out what we can. Okay, b squared. How much is that? 9. A squared is 16. All right, how about c squared? 36. 2 times a times c. Well, what's 2 times a? 8. What's 8 times 6? 48. Cosine beta. Okay. Next thing that I would do there is what? Yep. Combine like terms. And what would you get when you combine everything you can on the right side? 52. 48. Cosine beta. Okay, that looks good. Then you subtract your 52. Okay, so we got 9 minus 52 gives me negative 43. Now we got 2 steps left to get beta by itself. Yeah. Yep. Divide by negative 48. That's going to cancel the negatives and the 48. And when I divide by negative 48 on the left, that also cancels the negatives. Not a big deal if it doesn't cancel the negatives. I mean, sometimes it does, sometimes it doesn't. I guess it depends on the problem. Okay, so now we've got that. Next thing we want to do is, if we can simplify that fraction, we will. In this case, we can't. So just leave it as 43 over 48. If you type that in and you round it, you're going to get not a nice number. Right? So don't even round that off. Just leave it like that. Okay, and my last step. Yep. Take the inverse cosine. Before I do that, I always check, make sure the number in the bottom is bigger. If it's not bigger than the top, something went wrong somewhere. Or you tried to solve a problem that you shouldn't have, because this could have been a no solution. Right? Maybe you didn't check for that. I don't know. But in this case, we're good. So now do inverse cosine of 43 over 48. So that gives me an angle of 26.384. And in that problem, there's no reason why we all shouldn't exactly get that. There was no rounding anywhere in this problem until I put it in on the calculator. All right, so if you get something like 26.9, something's not right. It's 26.384. Unless I made a mistake, which that's always possible. All right, so now we've got another angle. We could think of it as law of sines, but it would be the case where we have side-side angle. We don't want to think of it as side-side angle, so we'd finish with law of cosines. To finish it with law of cosines, you would have to do one more angle. Okay. Is there any question how you would run through that one more time? Okay. Once you get one more angle, you can then add them up and subtract from 180. That would be the quickest way to finish once you get the 2. Or you could do law of cosines 3 times. The advantage of that would be is you could find each angle completely separate. So if you make a mistake on one, it wouldn't have any effect on the others. The downside of doing law of cosines 3 times? Well, what do you think? It's going to be a little bit more work. It's going to take a little bit longer to do it that way. Right. Now, this is the only problem this is the only case we've done this week where one mistake doesn't have to mess up anything else. There is a different way to do it, so it doesn't. Okay. All right. Any questions on that? All right. So that's a side, side, side. Okay. As far as like how many of these you'd see on a test, you'd probably have just 5 more. Five or 6 problems at most. Okay, because each problem has 3 answers to it. So if you had 6 triangle problems, that would really be like 18 questions, because you get partial credit for each one. But yeah, I wouldn't expect more than 5 or 6 questions on this test. All right, let's look at this one. So the last one we're going to look at is a word problem. And what we're going to do is find the distance between 2 points on opposite sides of a house. Now, you might think, well, why don't you just use a tape measure? Just measure straight across. Well, maybe there's some reason why we can't. Instead of a house being in the middle, pretend like it's a canyon, right, in the middle, or a lake. Like you're standing, I'm standing here, and where you guys are sitting is a lake. And I want to know the distance from that edge of the lake all the way over to that edge of the lake. It's not as easy to just run a tape measure. I don't have a boat. I can have somebody pull it across or swim across. All right, so I just want to find the distance across something. And for some reason, I can't directly do it. In order to be able to do that, I would have to set up a couple things. Okay? I could go to one end of the lake and put a tripod over there. Go to the other end of the lake on the land, put a tripod, and then I'm going to go stand at the third point on the side of the lake. What I'm going to do is I'm going to shoot a laser at the tripod that's at one end of the lake. When I do that, the laser is going to bounce back, and I'll have a little computer on my tripod, like a transit, and it'll tell me how long it takes for the laser to go out and come back. And knowing how long it takes tells me how far away it is. So I can figure out how far away I am from that end of the lake, and then I can figure out how far away I am from the other end of the lake. So what I'm trying to do is make a triangle here between the 2 points on the lake and me. So I'm going to get the distance to each point. And the other thing I have to keep track of is when I point the laser at the first tripod, then I have to turn. I have to keep track of how much I turn. Right? That's going to be the angle, one of the angles in my triangle. And it's very easy to keep track of how much you turn. If the device on the tripod swivels, just zero it out and then start rotating it and look down at what it says for how much I turned it. Okay, so I'm going to end up with 2 sides and an angle. Now, I said to use your imagination about why you couldn't just directly measure it. Maybe it's 2 sides of a canyon. It's not easy to get across it. 2 sides of a lake. For whatever reason, we can't measure it directly. In our case, there's danger between the 2 houses. First of all, we've got a giant crab kind of thing. Right? It's big, it's huge. We've got a poisonous tree frog, and they could be above us, and they could jump down on us if we try to get in there. It's woods and stuff, it's dangerous. And then we have the Easter Bunny. Doesn't look like he's dangerous, but he's got eggs. You could throw him. You don't know. So that's why we don't want to measure the distance directly. We're going to use math, and that's going to keep us safe. Now, I needed a picture of a surveyor. I don't have a picture of a surveyor, but I got this guy. This is my World War I trench soldier. Trench soldier. Okay. So what else that? We know what's going on there. So let's make our triangle. So that's the distance we want to know, and we're going to stay away from there. We got that, and we got that. All right. So it tells us that the distance from, let's see, surveyor walks off the distances. All right, it's safe to walk over here. Maybe again he's just using a laser, so he's at a safe distance from all those creatures. 50 feet and 70 feet. says the distance from him to house A is 50 feet. And I know it's 50 because it says respectively. So A comes, then B comes. So the distance to A, then B is second. So 70 feet is the distance to B. And then it tells me the angle ACB. So the surveyor is standing at point C. ACB. That just happens to be 70 degrees. All right. And what we want to find, we've already used A, B, and C, so I don't want to use those letters again. I want to find X. That's the length between houses A and B. All right. So based on the information that we have, what kind of triangle is this one? Yep. Right, it's a side, an angle, between, and a side. So that means it is law of cosines. What would we have to start out with in our formula if we want to find the distance between houses A and B? So I want to know what I would start out with in that box if I'm trying to find the distance between houses A and B. X. Yeah. So we're going to start out with x squared. And what would come in the next box? 50 squared, 70 squared. Okay. And then the next in parentheses. Oops, that's a side, not an angle. So 50 squared, 70 squared, and then 2 times what? 50 times 70 times, I did it again, times the cosine of, what's the angle across from the side I started with? 70 degrees. Yep. So this 70 is the side on the right. This 70 is the angle at the bottom. I probably shouldn't use 70 and 70. Oh, well. Okay, so now we just have to do that out. Okay, let's do what we can. What's 50 squared?
2,000.
2,000, how much? 2,500. Yep. And 70 squared? 4,900. Oops. I think I put an extra line. Sorry about that. What's 2 times 50? 100. What's 100 times 70? 7,000. Cosine 70. We got a little bit more we could do. What's 2,500 plus 4,900? 7,400. That's pretty much all we can do, because the next step would involve multiplying 7,000 times cosine 70. That's going to be a decimal. Okay, so anything that's going to result in a decimal, I don't want to do that till the end of the problem. So there's only one thing I need to do left to get x by itself. Yeah?
Square the x?
So right now it is squared. I want to get rid of that.
Yeah, what is square root?
Take the square root. Yeah. So take the square root of each side, and that's what we'll type in. And that'll give us the distance between the two houses. Okay, so we've got square root of 7,400 minus 7,000 cosine 70. Okay, so there was no rounding in that problem till the very end. So distance between the two houses is 70.752. 70.752, and I think it was measured in feet. Yeah. Okay. So that's the distance between the two houses. And the best part is we did it safely. We avoided all the perils. Any questions on that one? All right, so that's law of cosines. All right, so because, again, these can take a little bit of time to do, not a ton of them. So it's 9, 11, 13, 17, 25, and 27. Okay, so the test tomorrow is on 4.2 and 4.3. So we'll cover law of sines. Okay, all three cases. Angle, angle, side. Angle, side, angle. Side, side, angle. And remember, with side, side angle, make sure you check for 0, 1, or 2 solutions. And the only other thing that is on it is law of cosines. 2 types we get under that: side, angle, side. Side, side, side. With side, 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 you do have to check for 0 or 1 solutions. But that doesn't take anywhere near as long as the 0, 1, or 2 solutions. So there'll be at least 5 questions, because that'll cover 1 of each type, and then I'll probably repeat 1 of the types. Okay, so probably a total of 6 questions. Each question has multiple answers, so you can get partial credit for each one you get right. Okay. And I'll be after school today if anybody needs to stop by for extra help.